Right, so we are carrying on from where we left off with our linear functions work, right? Now, just to remind you where this all started from, this module, this topic is about solving simultaneous equations, so don't forget that. Yeah? So when we were talking about simultaneous equations and solving simultaneous equations, what were we doing? So there's kind of an overarching task that we are trying to do, a problem that we're trying to solve, and then we have lots of different methods for solving that problem. So when I say simultaneous equations, what are we trying to solve? No.
Find the value for x, or
Find the value for x and y. More to it than that. Why do we need simultaneous equations to find the value for x and y?
You have more than two.
Pardon?
You have more than two unknowns, or they're the same.
So the x and y are unknowns. But why do we need simultaneous equations?
Because x and y.
Shh. Let's go.
Find the line.
To find the line. No, I wouldn't say that was like the whole issue. Anyone else? Yeah.
Is it another way of finding x?
It's not really another way. It's we need to find x, and we have lots of ways of finding
So
what
it's
x
a
is.
way.
But we need to actually find x and y, which is what Manaya starts off with. But why? For what purpose? We've got an unknown value of x and an unknown value of y. Okay, we've got two unknowns. So to be able to find, well, when we say find two unknowns, why would we want to find the two unknowns? Because we want to know, right?
To find the formula.
We've probably given the formulas or the equations that you're probably talking about.
You want to find it so you can put in the curly something. So you can have a general equation that you just slot in the number.
Okay, so do you not remember though when we had simultaneous equations, we already had the equations, no?
Maybe I'm thinking of something different.
Maybe you're going a step further though as well, where we have to form the equations. Vinay?
does it have anything to do with graphs?
What graphing was part of it, hence we're still doing the graphing. Yes.
Wait, so the
Yeah,
answer
Hayley?
is graph.
Try and think of what we did, some problem solving questions in context. So for instance, we did that whole section of work on forming the equations to start with and then solving them. Do you remember the work on, if you have 3 lots of one number and 2 lots of another number and they equal 15, yeah? There's no way of knowing what my two numbers are. So when we needed to have a second piece of information, like 8 lots of the number and 3 lots of the other number equal a different value. So we're problem solving. Now, we could apply that, for instance, to questions like, I don't know, you've got some coins in your pocket. Yeah? You've got some 10-cent coins and you've got some 5-cent coins, and in total you have $5.20. Yeah? So you can't figure out how many 10s and 5s you have unless I tell you another piece of information, like in total you have 30 coins, for instance. So you've got the 2 pieces of information, and we are trying to find the 2 values, the variable values, which you call them variables. We're trying to find those variables that fit both pieces of information, so we can solve a problem. That's what we're doing with simultaneous equations. We need the 2 equations to narrow down our options, because if I have 2 unknowns and only 1 value, that's homework, Jen, wasn't it? Or it's not now, not for now, work. I've got 2 unknowns and only 1 value for them. We've got an infinite number of solutions. So, for instance, if I say 2 numbers add together to make 8, what are my numbers?
4 and 4.
4 and 4,
5 and 3.
5 and 3, 6 and 2, 1 and 7. Yeah, exactly. Decimals come in as well. They're actually an infinite number of solutions. Yeah? Alright? So I have to give you a second piece of information. So that's what it is with simultaneous equations. So try and remember what we're doing. Now, when we had simultaneous equations, we've got the two equations, whether we formed them or been given them. Initially, we had algebraic method of solving them. We had two algebraic methods. What were they? A substitution method and an elimination method. Could someone verbalise what the elimination method was about? Right?
The elimination method is giving two scenarios to. Is scenario the right word?
Okay,
Or
it
like
works.
two equations or scenarios that help. I don't know what I'm saying. Never mind.
Ali, you were going
But
to
I
say.
know what it is.
If you have like 2y plus 3x and then 5y plus 3x, then those kind of eliminate, and then you just have to work with the other.
Yeah. What were you going to say, Hayley? So basically what we have, Gabriella, what, you going to say something different?
Yeah, I was just gonna say that you want to eliminate one of the like x or y.
Yeah.
So you just have so you can solve y or the other.
Or the other. So okay, in simplest terms, the elimination method was about setting up your two equations, or scenarios if you like, so that you can see the impact that one variable has on the answer. Yeah? So if I can see, well, if I have 3 x's rather than 2 x's, the answer goes up by 8. I know that x must be equal to 8. But that only works if one of the variables doesn't change. Do you remember that? So we could, if both equations had different values for x and y, what would we have to do?
You have to times each by the other to make it.
Not necessarily by the other,
Oh, no,
but
no. So like you have 5 and you have
Yeah.
3 times the top one by
Yeah.
3 in the bottom.
so that is called doing the what? Finding the
Multiple.
lowest common multiple. Well done. So we find the lowest common multiple. So we've done elimination. What was substitution? Gabriella.
So when you have like the y equals something, and then you have the next equation that's x plus y.
Yeah.
Means that you just substitute the y instead.
Yeah, so if we know that y equals something in terms of x, you can replace the y in the other one with the x, and then we've got an equation with only x's in. So we've done elimination, we've done substitution. The next method was a graphical method. And how do we know using graphs the solutions of simultaneous equations?
There's them.
Where they cross.
Where they cross. Do you remember that question that you did in your little quiz thing? And all I had to write on the majority of people's work was use the graph. Do you remember the two graphs crossing? And you tried to do elimination method rather than just read from the graph? Okay? Remember that? Yeah? So we're looking for where the two graphs cross. Now we did that mainly by using your calculator, right? So you put it into your calculator, you solved it in that way. But what we were then moving on to was, what if you had to draw the graphs yourself? Right? So we had the intercept or the gradient and intercept form of the equation, and you had the general form of the equation. And we had to be able to draw the lines to find out where they cross. So we need to know that you can draw the lines given the information. So we looked at gradient, we looked at how to find the plus c bit, you've looked at how to convert from gradient intercept into general form and all that sort of stuff. And then once you're happy with drawing the lines, sorry Asma, I'm struggling to keep you awake here, aren't I? Right. Once you can draw the lines, then we can go back to being able to solve the simultaneous equations using the lines. And that's what I'm giving you with this pack we're talking through today. And we've also got stuff on what if lines are parallel, what if they're perpendicular, and that also is in this pack I've given you. But to start with, there are certain equations of lines that catch people out, like these ones, that are very, very easy, but unless you're aware of them, you might struggle. So when we've got a line like y equals minus 1, I heard the mutterings, oh, do we just put the 1 point? Well, that kind of suggests you don't understand the equation of the line. So does anyone, are they certain they know what the equation of y equals -1 would be? Ed?
Is it just a vertical line going through -1?
It's not.
Horizontal line?
It's a horizontal line. So your y equals -1 should be a line. Let me make sure it's visible. Should be a line like this.
Yay! I got it! That's great.
Now, how do we know that that's the equation of that line? Well, do you remember I said a line is actually not a line, it's what?
A bunch of points attached together.
Okay, so at the moment what people think is that these are the only points.
But there's points in between.
Exactly, there are an infinite number of points in between. Now, the equation of the line must link the x value, okay, the x value to the y value. So this point here has an x value of 1 and a y value of -1. So we need a rule, that's what the equation is, that links every x to every y on that line. So like this point, for instance, has an x value of 6 and a y value of -1.
How does it have -1?
Because it's on the green line and the y coordinate is 1. This coordinate here has an x value of -4 and a y value of -1. Now here's the thing. There's no direct connection between the x value and the y value, because the x value always changes but the y value never does. Okay? So what do we know? Well, we know then that whatever x value I put in, the y coordinate will always be -1. Hence the equation of that line is the y coordinate will be -1. There's no x in it, because x can be any number you like. The y coordinate will always be -1. Now, as soon as we have the x coordinate changing what the y coordinate will be, the line will be what? Diagonal across the page, and we'll have something with y equals x something. So this one, y equals -4, we just know that every coordinate is x, whatever it is, but y has to be -4. Okay? If we go down, this time we've got the x's, so the y coordinate can be anything it's like, but the x coordinate will always be -3. And what does that look like? Vertical line going through -3.
I should have kept on going.
X is -1.
Good job.
Okay? Now, why do people get confused?
I got confused originally because I thought that everything had to go in a diagonal
Okay.
line.
Lots of people think that, but obviously there has to be vertical and horizontal lines. Also, there's a confusion because, I don't know whether it's in below, what about the y equals 0 line?
I just did a cross in between the 0.
Well, the y equals 0 line is actually the... So this is where people get confused, because the y equals 0 line is actually the x-axis. So that's why people think, oh, if it's horizontal, it's x equals, because it's the x-axis. But actually, the coordinates on the x-axis are always y equals 0. The x can be anything. All right? So this one, y equals 2, horizontal or vertical? Horizontal through 2. And this one, x equals -4, horizontal or vertical? Vertical through -4, x equals 3, down through 3. Okay? Make sense now? Does that clear up anything for you about? Yeah? Okay. Right. We're going to move on then. Let's go to this other booklet I've given you. Have you all got your booklet in front of you? Right, so looking at this first question, on the grid, draw the graph of y plus 2x equals 6 for the values of -2 to 4. Now, this should be an absolute banker of a question for you. Easy marks in an exam. Do you all know how you would go about doing it?
I have a guess.
Have a guess. Sophia, what would you do?
Do you like rearrange the equation so that it's y?
You can. You can do that. So should we write that down? So we've got y equals, y plus 2x equals 6. Do you want to rearrange it for us?
Y then 6 minus 2x.
So y equals 6 minus 2x. Now, that is in what form?
Y. F. General.
Nope. This one is in the gradient intercept form. So,
So we would do 6.
also written as y equals minus 2x plus 6.
Why would we want to rewrite it?
Well, it was one way to do it. So we've got the minus 2x and we've got the 6. So if I just rewrite it, keeping the symbols the same, right? Now this is in gradient intercept form. Now do you remember gradient intercept is y equals mx plus c? Remember that? Okay. So we can use gradient. Okay, so I think m is the gradient and the intercept is the plus c. Do you remember we did all that work on if these are the coordinates, how do you find the gradient, how do you find the plus c? Remember doing that? Okay. So how do we use this information to draw the line then? So I've got minus 2x plus 6. How do I do it then? What do I use? You could, yeah. There's several ways to do it. You can just, what numbers are you talking about?
The -2 to 4.
Yeah, do that. Right? But we could have done that before as well. But yeah, we can substitute the values in.
Do you draw, like, you can do your first point at 6?
Okay, we'll come back to you on that one. Yeah, that's what I was expecting. But let's go with what Gabriella was saying. Do you all understand what she means by substitute the values in? Yeah? So basically what they're saying is in the question, using the x values from minus 2 to 4. Now, notice that my x-axis has more numbers than minus 2 to 4. So I don't want to use minus 3 and I don't want to use 5. I only want to use minus 2, minus 1, 0, 1, 2, 3 and 4. Now they're the x values and we've got to figure out where on the y-axis, that the y-coordinate, what would the y-coordinate be? And we've got to use the equation. So how do we work out the minus 2? So put it in. So if I know that x is minus 2, y will equal minus 2 times minus 2 plus 6. So that would be 10. So because I've got minus 2 here and the x value is minus 2.
But couldn't it be any one of them?
Yeah, I've picked the one that I want to work on at the moment. I chose as minus 2.
Okay.
So I'm putting the minus 2 in for my x value there. Alright? So I know then that it goes at, minus 2 goes up at 10. So there's my first coordinate.
How many coordinates are we looking for?
Good question. How many coordinates do I need?
2, but 3 would be better.
Okay, why do you say that?
2, so you can make a line at 3, so you can make sure all your points are right.
So when we know it's a straight line, you only actually need 2. You join those 2 points together. Alright? The ones at either end would be very helpful. If you don't know it's a straight line, you'll need more than 2 to check. But we know it's a straight line. Anyone remember why?
It's a linear.
But how do I know it's linear?
There's no
Good, there's no squared, it's x to the power of 1. So if I've worked this one out, what would be a sensible one to do next?
4.
4. So let's do when x equals 4. So we've got y equals minus 2 times 4 plus 6. And what's the value?
-2.
So that's minus 8 plus 6. So I've got y equals minus 2. So at 4, I can put my mark at minus 2, and my line goes like that.
And it's 6.
Yeah, see, now we notice that where does it cross? Crosses at 6. And where does the minus 2 gradient bit come from?
It has to be rise
Is
over
it?
run.
Yeah.
Rise over run, good. Which comes in as start at the point that I know, and rise over run needs to equal minus 2. So that means if I go across 1, I have to go down, because it's minus 2. And you'll notice it does look. So for every 1 across, we go down 2. So actually, I think Jen was going to explain how we could have done it like that.
Yeah.
So what Jen was going to say was, until I cut her off, because of the plus 6, we could have just put a point on the y-axis at 6, and then done the gradient of minus 2 is across 1 down 2, and we could get all the points that way. So we don't have to do the substitution, but it's good if you understand both ways. All right? How do you feel about that?
I feel amazing.
Amazing.
Why
Good.
did we go down by 2?
Sorry, Gabrielle.
Do you not have to plot every point?
No, we don't have to plot every point. Now, just pointing out something, my year 11s have just been doing a past paper for me, and they've been having to plot lines. They've had to do straight lines, but they've had to do quadratics as well, plotting points. And what some of them did was this. So they just plotted the points, okay, and left it like that. Okay, and the reason why they did that is because it said minus 2 to 4. So they thought, well, the points are only minus 2, minus 1, 0, 1, 2, 3, 4. But you guys know that what falls in between those points?
Points.
Lots of points. And you've got to draw all the points, an infinite number of points. And how do you draw an infinite number of points? You draw a line. Okay? It's the only way to draw an infinite number of points. So that's why you have to draw the line.
How
Yes?
do you know the rise over run?
Because it comes in the equation as minus 2. So do you remember the run was this bit? So that's the run. And the rise. So we know that the rise divided by the run, which is the gradient, has to equal minus 2.
So
Okay.
it's 1.
So that would be minus 2 over 1, or minus 4 over 2, and so on. Yeah? Be minus 6 over 3. So you can see from the line, it doesn't matter what I do. So that's 1 over 2, minus 2. 2, if I went 2 across, I need to go down 4. And you'll notice that it does. Yeah. If I went 3 across, you'll notice that I have to come down 6. So that's your rise over run equaling minus 2. Okay? Alright.
I can do the next
So, tell you what, yeah, this one would be an ideal one for you to practice. I do want to show you another method, just so you've got an all-rounded knowledge, but have a go at question 2 for yourselves.